Hello, my math muffins. This is going to be a video that's going to go over the first lesson of the new unit. And so our learning target for today is I'll use the laws of exponents. So we're going to talk about exponents and expressions that are being multiplied. Ugh. Let's change that. There we go. And so that I can simplify an expression. I know I've got it when I only have positive exponents and one of each variable. So once you're done simplifying, we're going to be looking for making sure that we only have one of each variable, and then also that we have just positive exponents, which will make sense in a little bit. A couple of reminders. So this is what the video that you're watching after the test. Make sure that if you haven't done so, you glue in your notes. Glue in the new table of contents in the notes section. That the calendar, you can take a look over that with some dates. There's like 2 quizzes this unit and a test in about a month. And then we're going to watch this video, which you're doing now. So hopefully you're at step 2. Everything I write on the notes slide, please make sure you copy in your notebook. And then after this video is done, you're going to complete a couple practice problems, so you can just kind of pause the video right at the end. Bring it to me, get checked, and as long as they look good, at that time you can ask any questions if you have any. You're going to start your homework, which is Math Space 6.02, which is multiplying rules of exponents. Okay, just as a reminder, if you didn't do your homework during any class period 2, if you didn't complete your homework on time, remembering to start it as soon as you get to class. And if you have time to work on it in class before we get started with the lesson, we're talking about the homework and the warm-up. That's a great time. You have to fill a snail mail form out, including your mastery level score. So if you made to 60, or if you got to like 62 or 68 or whatever, make sure that you fill that part in. And if you're absent, don't do the warm-up. Instead, get your absent work from the folder. And you want to copy your notes in from last class. They're posted on the HyperDoc, as well as you can grab them from a partner. Then if you have time to work on the homework, which you probably won't in class, make sure that you work on that at home. You have till the end of the unit in order to complete absent homework for 100% credit. Okay. And when you finish, you have to snail mail it because all of that stuff's logged, and I don't get notified of any of it once it's been completed. So I need to be let known to go back in and check within the math-based assignment. Alrighty. Sorry. Okay. So what we're going to do, and I should probably clear these slides out because I already posted your notes, is we're going to go through just kind of general exponent stuff. And then we're going to get into the rules. And it's going to be kind of long just because it's a lot of looking at the patterns. Let me see. I obviously am in the wrong copy. Okay, there we go. So we're going to do that first. So like I said, you're copying everything on the note screen. So anything on here I'm going to be looking for when you come up to show me the couple of problems I'll have you work on. So if at any time I talk fast, so if any time you want to pause it and then get your notes copied in, or watch it first, copy second, or whatever, vice versa, feel free to do that. Okay, so there's kind of 2 different ways that we look at exponents just generally. You have expanded form, which is on the left side column, and then you have exponential form. So that means writing using exponents. So we'll start basic. Expanded form would be like x times x times x. Exponential form, that would be x to the 3rd. So that's kind of, we're just introing this. Expanded form, x times y times y times y would be x squared times y to the 3rd. Or, because we know when variables sit next to each other, that's multiplication. It would just be x to the 3rd, y to the 3rd. Ooh, except it wouldn't be x to the 3rd. It would be x squared. Sorry. So that's exponential form. Now, kind of going the opposite of a squared, writing in expanded form is a times a. And just as kind of general vocabulary too, when we refer to the bottom number, like the x or the a or the 2, whatever down here, that's called the base. and this is the exponent. So I don't know, you can write that down, but if you don't remember that from previous math years, but if you do, don't worry about it. Okay, so a squared would be a times a, b to the third c squared times d. For some reason, mathematicians like to put our variables in order from an alphabetic order. So that would be b times b times b. If we're expanding this, times c times d. So that's what expanded form would be for that. And then this one, 2x times 2x times 2x, is the expanded form. If we were to write it as exponential form, you would just write 2x to the third. So kind of going backwards on that, xy squared would just be xy times xy. You could also, I mean, it's the same thing, like xy times xy, or even just writing them next to each other. It's all the same. All multiplication, parentheses, dots, you'll see them all regrouped differently, depending. Okay, so now on to the lesson-ish part of this, the first part. There's kind of two different multiplication properties. The first one is just multiplication basic. The other one we're going to be taking a term and raising it to another power. So we're going to start out kind of basic, and the easiest way to simplify when we have any type of multiplication between some variables, especially variables that are the same, like in this case x and x, is by writing this as expanded form and then rewriting it using one exponent in one term. So I'm gonna kind of like color code this just for the first couple of these. So x to the fifth would be x times x times x times x times x, and then if we had x squared, that would be x times x. So instead of writing these as two separate pieces of the multiplication, we can rewrite it. We have x, putting them all together, 1, 2, 3, 4, 5, 6, 7. So x to the 7th. So that would be the simplified answer. And we know it's simplified because we only have one x in our answer. And the variables are positive, or the exponents are positive. Okay, so that's kind of the intro. We'll do a couple more. So this one is y to the 6th. And again, you can actually just write it right next to the 3, 4, 5, 6. It's hard to color coordinate with red. And then y squared, so y times y, or just yy. And that y would just be this one. So if you're multiplying, and I know I'm trying to color code, but if you're multiplying all these together, this is really the same thing as y to the 9th power. Right? 1, 2, 3. It's all being multiplied. So in the end, you can kind of rewrite it. All right. So that's kind of what we normally do. We expand out from the exponential form to expanded form, and then we regroup it. Anyway. Okay. What about when we have coefficients? So this would be like 4xx, and then we have 2, 1, 2, 3, 4, 5. So in this case, let's just look at our x's first. So 1, 2, 3, 4, 5. So that means we have x to the 7th power. Your coefficients are just numbers, so you're just going to go ahead and multiply them together. So 4 times 2 is 8. So that would be the simplified version of that. It'd be 8x to the 7th. Okay, a couple more, and then we'll hopefully, you might already have been seeing some patterns. And like I said, make sure you're getting all these in. It's a lot. They don't take long to solve, but I want to make sure that you have them all in your notebook. All right, so negative, this is really just like -1, so we can even write that. -1 and then y to the 3rd times 3y. There we go. So that's going to be -1 times 3, which is -3. And then y. There we go, to the 4th. Okay. Alright, so the last one I put like a bunch in there just to show you how that would work. So for this one, you would just expand this out. This is negative 3x squared y. So there's two x's and one y being multiplied. And then negative 5, and then a 1, 2, 3, 1, 2, y's and a z. So each exponent the exponent only goes with the base that's directly underneath it. That's fairly important. Especially we get into some more of these like complicated ones. So we're going to go ahead and just multiply these numbers together. So negative 3 and negative 5 would be 15. And then the x's, I have 2 here and 3 here, so that's x to the 5th. I have 1 y and 2 y's, that's y to the 3rd. And then there's only 1 z. So that'd be your final for that. Alright, so hopefully by now, that was a lot of examples. 5, that's a lot. So you might be able to see some patterns. And some of you have probably already seen it. Either in your previous math class or you've done these and you're like, why is she spending so much time expanding when there's a much quicker approach? So you can always expand and simplify, and I will usually encourage you to do that just because students conceptually seems to make more sense for them to do it that way. But you'll notice that when you're looking specifically at the exponents 2, 5, and then 7, this exponent we're going from 6, 2, and don't forget kind of the base rule. If there is no exponent, the exponent's a 1. That's a good assumption to talk about as well. So 6, 2, and 1. So that would be 9, 2, 5, 7. There's another 3 and another 1, 4. And you can only look at the ones that are the same. So 2, 3, and 5. I'll just like change colors. 1 and 2 and 3. And then the last one on here, which is just the 1 and 1. So there's kind of two ways you want to have this both. Like I said, everything on this slide, make sure you're writing it down. When you're multiplying terms with the same exponents, which is what all those examples were above, you can either expand and simplify, or you can add the exponents of the same variable. So kind of taking, if you have y to the 2nd times y to the 3rd, you could think, well, that's going to be y times y, and then y times y. Or if you're comfortable with that and you know kind of visually what that would look like, the bottom part that I just wrote, you could just go ahead and add them together and that will give you 5. If you're really good at memorizing things, that's excellent. If you're not good at memorizing, I would stick with the expand and simplify. So you can always expand it out, you can always write an expanded form, and then just rewrite it using one of the variables of each part. Okay, so that's kind of the first part, and I think I even have like a sign. Oh, probably not first period, but there's a general rule that like a to the n, as long as the bases are the same, you can, and you're multiplying them, you can add them together. So that's like the base rule for that one. Okay, one more part, and we'll do a couple of these, and then hopefully you'll see a pattern as well. So this is when we raise a power to another power. So we're going to write that out kind of like we did in the table in the front. This is really x cubed to the 2nd power. So if I was going to write this in expanded form, it would be x cubed 2 times because it's to the 2nd power. And from there, you could write it even further, and you could write the first x times the 2nd x. And then that would be x to the 6th power. You might already see where the 6 could come from so quickly, but we'll just do a couple more of these. So y squared to the 4th power would be y squared times y squared. It's whatever's on the inside to whatever the number is on the outside. That's how many times you're multiplying it by. And that'd be 2 of each one of these guys. Y squared. You could fully expand it until all of your exponents on every variable you have is a 1. And that would be y to the 8th power. And like I said, make sure you're pausing these because I know I'm running through them kind of quickly. So then if you have 3x squared squared, that would be 3x squared times 3x squared, which would be 3xx, 3 times 3xx. And again, when you get here, you want to go ahead and multiply these together. So that's going to be 9x to the 4th power. And that's actually one that we're going to look at here again in a second. And then the last one that I have, negative 4xy cubed, 3 times. And sometimes you see it like this. Instead of the dot, you'll see the parentheses. Negative 4. There's just 3 of them. We'll multiply all the negative 4's together, and that's going to be negative 64. Is it? Yeah. And then you have 1, 2, 3 x's. And then even at this part, I can write them all out, the y's. But if you have 3 in each set, then that means that there's going to be 9 y's all together. So that'll be your final for that one. And like I said, we know it's right because we only have 1 x, we only have 1 y. So that's always kind of your check at the end. So after you do a bunch of these, like a lot, hopefully you'll start seeing some patterns again. So you can always expand your power and then rewrite it. So kind of writing it out just like I did in all of these examples. Or instead, you'll notice that we're going from, so just looking at the exponents, 3 to 2 to 6, 2 to 4 to 8. This is interesting too. Don't forget 1, 2, 2 to 9 and 4. So we'll look at that one in just a second. And then this one, we're going from negative 4 to the 1st power to negative 64. You're going from 1 to 3 to 3 to 9. So you can see all of the exponents are really being multiplied. So we're talking about multiplying the 3 times the 3 to get the 9, the 1 times the 3 on the x to get the 3 exponent on the x as well. There we go. So you have to be careful because with questions like this, students will be like, oh, it's easy, it's just 2x to the 6th power. But just remember, however many terms you like, not terms, however many pieces of the term that you have, each part that 3 has to get to. So you could do the 1 times the 3 to get 2 to the 3rd, and then you could do the 3 times the 2, and that will give you x to the 6th, which would be 8x to the 6th. Or, again, you can always expand it out. So 2x squared times 2x squared, writing it in the expanded form, and then even further expanding out the x's. So that would be 2 times 2 times 2, which is 8, and then x times x, x times x, x times x would be x to the 6th power. Like I said, if you need to go back and watch this over a couple of times, that's totally fine. Do what you gotta do. I'm gonna stop the video here. I want you to complete these questions here. So you'll notice the top 3 were like the first section of the notes that we did. So looking back, don't forget that this one has a coefficient of -1, and the bottom 3 are the ones that were from the second section, really the bottom 2, and the last one kind of combines them all. So simplifying, combining them all. Feel free to ask me questions if you have any, rewatch it, and once they're checked off, you're just going to work on your math-based homework, which is 6.02, so you can get a good head start on your homework. That's kind of why I made the video so long. It's because we're not really doing any practice specifically on this, just the U-turn part. So, thank you so much for watching, and I will see you talking with you soon.